Everyone hear me and see the screen okay?
Yep.
Okay. I just had a power surge or something. So checking that I'm still on. Okay. So, okay, if no questions, then we'll go ahead and head into the last section here. It'll start to get more interesting, I think, as we build on this foundation that we've laid. But before we do that, just at the bottom of our previous section, there's a line that says consider this object diagram, and that object diagram, if you click on it, is you should open a new tab if you click on it. That's this guy here. So I think it's a pretty expressive diagram, and I think it's interesting to look at this and you know, where it says third commit here, to kind of go back and, you know, see how we can, if that maps for us to something we understand on our repo. So for instance, if the latest commit in our repo corresponds to this third commit, what SHA would that be? Assuming this is where our head points.
8C88.
Exactly. And what tree would correspond to this diagram? How would we find that out?
If we do git cat file -p and then the commit for the objects, .git.objects, /objects, I think.
So you're saying -p of, and then what I type after -p?
Oh, .git /object /8c/88.
So that would show me where it's at in the, yeah, if I did this. So you're saying if I did 8c, that would show me where that, yeah, where this is at in the Git database. So if I wanted to find out what tree that commit encapsulated, how would I find that? What tree belongs to that commit, I guess, is another way to say it.
Oh, I think if we do cat file -p head, it will show us the tree.
Okay. Yeah. Yeah, because head is just this 8C88, right? This thing that we looked at up here, exactly. So yeah, so then there's a tree. So this tree right here would correspond to our tree, you know, right here, that this commit would point to. And then what about some file in that tree? How do we find that? Or directory, of course.
And that's where we can inspect the tree commit, right?
Uh-huh. Yeah, the tree SHA.
The tree SHA, yeah.
Yeah.
Tree SHA.
So yeah, so same way, use git cat file again, and then this guy here, C16C. Yeah, and then everything down here, you know, corresponds to what the tree contains. And we haven't really looked at the tree much, but you know, basically, you know, each one of these is a blob, or it could be another tree, right? If it's a directory is another tree, as you can see here. So it's a recursive structure. That's why it's called a tree, and it has the file name in it. If we look at our hi.txt, right, the one we're familiar with, that's where Git stores the file name. It doesn't actually store the file name in the content of the file. Right, that's this. It's just a blob. It just has the content only. but all these sort of attributes of the file, including its name and you know, where the content lives, and then also this over here is that's also the same sort of thing we looked at when we looked in Linux to see what the permission structure was. This is a numerical representation of this permission set over here. So, you know, that's what, I won't go into the details of how that is, but it's basically octal notation or base 8 notation that shows, you know, what's going on over here. So 644, for instance, corresponds to, you know, bit 110, which is 6, bit 100, which is 4, and 100, which is 4. So you can kind of see how that's represented here. But anyway, it's the permissions that go on into Git along with the file name and the content reference. So that's a tree. Okay. So far, so good. So yeah, so the last two commits, and you know this. How would you find out what this commit was? What does that correspond to? The commit before the third, or commit before the last commit. How would you locate that? So if we looked at head, one of the attributes of a commit SHA is its parent. So the parent here would be, you know, the commit that's pointed to. This is how Git can draw this graph of commits. So I don't have any examples here, but, or do I? No, there's no examples of a merge commit, but if you think, you'll see merge commits that have two parents, that basically by definition, that's a merge commit. So you'll have more than one of these parent records if you do a gat file -p. So actually we can do this here. We've got our head pointing to some new branch, so we can merge that back into master if we want. GB is git branch. So we're on some new branch. So let's just go ahead and actually merge master onto here. Okay, we'll just use that. Okay, and now we look again. And now we've got a commit up here with two parents. You know, your master branch and then the last commit you made, or that I made. So let's examine that. So there you can see there's two parents in that commit record, which tells you that it's a merge commit. So that's exactly what Git uses to draw this graph up here is this information in the parent records. Okay. All right. So let's switch gears, come to home stretch here. This will get us ready for next session on Wednesday, April 1st, I believe, which will be the actually workflows, different workflows we can use. So once we have this tree section under our belt, then we'll be able to do interesting things with it. So let's clear our screen here a little bit. Quit, Q for quit, Command K. Okay, so trees. So I've talked about head. We've you know, done git adds and git commits. I snuck in a git reset there, and this is where we're going to kind of understand what is going on with all those commands in a very in an integrated way. So if we have, let's see what our status is of our repo. All set. Let's go back to master. Okay. So normally you, you know, if you're up the fairway and you make a change to a file, so if we echo something into our hi.txt file, we'll append it instead of clobbering it. That would clobber it. Don't necessarily want to clobber it, so let's just append. Okay, there's hi.txt. So we've got it modified. So let's see what's going on here. You've got master branch. Says it's not staged for commit. So where is that change right now with respect to head or the index or the workspace? How many places is that change of those three?
Workspace.
Just the workspace, exactly. So it's, you know, shows up in red, Git helps you with that. How do we get it into the index? So let's see what that looks like in status now. Actually, I'll leave that there and do that in the other, so you can see them both easily. Okay, so before it said not staged. So now it is staged, right? That's what the index is a staging area. So how many places is the change now? Or which places, I should say?
Two places in the index, in the workspace.
Right. Yeah, we're progressing the change on its way toward the repo. It's not strictly in the repo yet, although Git has kind of teed it up for putting in the repo. There's been a blob created that corresponds to this guy. I think there's like a Git ls files. You know, yeah, I'd have to look to see exactly what it is, but there's ways to look at the index, and there's SHAs that have been created just to get everything set up for the final commit operation. But then, yeah, so then we can go git commit, give it a comment. Okay. And now we look at our git status. Nothing to commit. Working tree is clean now. So that's the green path, right? That you make the change, you add it, moves it into the index or staging area, and then from there it goes on into the repo. So if you come from another source control system, that seems a little bit sort of unnecessary, because, you know, if you're in Subversion, you just commit it and it goes in. There's no intermediate step here. But because of the way that Git manages your changes, the index is actually very much a part of the way you want to work when you're in Git. So what if you screw something up? What if you didn't want to commit that file? Or what if you committed it, but you forgot you wanted to put another file in as well, right? Say you had, maybe you had there.txt. Right? And you do your git status, and you say, shoot, you know, somehow I missed that, didn't get added. I want it to go in too, because it doesn't make sense, that file doesn't make sense by itself. It needs there.txt as well, right? So you could put another commit in, right? You could just go ahead and git add and git commit. But then somebody who gets a hold of your repo is going to go, well, they screwed up. Or I don't understand why these weren't together, or, you know, it'll be confusing. You're communicating, you know, in a very, very real way by the commits that you make and the comments that you make and the files that you commit, and, you know, the change sets that you pass along to your team, or even to yourself 6 months later, right? Because I forget an amazing amount of stuff about what I've done in that length of time, or even less. So it's important, it's useful, it's helpful to be able to edit, to author your commit and make it like you want it before you get it up there and push it out to a different repo to be consumed. So this is where Git Reset really shines. So a little bit of text here about what it does. I think it's confusing that it's called Git Reset, but you know, it is what it is. So the way I remember it now is that it operates with respect to a commit that's already in the repo. So if we look up at here, you know, we're basically trying to orient ourselves with respect to something in this graph when we do a Git Reset. Usually it's going to be just like one commit back, but it doesn't have to be. It could be back, you know, several commits, or you know, something completely different than anything here. So that's, I think it's key to understand that Git Reset assumes that there's something that it's aligning your stuff to. It's aligning your workspace and index and head to a commit that's already there. If you just say Git Reset, it will assume that the commit you want to operate on is whatever head's pointing to. But you can give it something else as well. Also important, it's not necessarily it's not the SHA that head's pointing to, it's the branch head's pointing to. So I'll show you what I mean. So we look at what head is pointing to. That's one way to see it, but what I really mean is in your ADOG listing, head is pointing to a branch. So when you do a reset, it doesn't just move head, it moves what head is pointing to. So when we reset, head will still point to master, but master will be somewhere else. So it moves the branch. So let's try it. So reset has 3 options. I've listed them here in this table. Soft, mixed, and hard. Kind of a mnemonic for how much it resets. Hard is the hardest reset of all. It could, you know, obliterate stuff in your workspace if you're not careful. You know, if you don't understand what it's doing. Mixed just moves head and index, but doesn't change the workspace. And then soft only moves head, or I should say what head points to. So if I say git reset -- soft, now what happens if I just give it head? Any guesses?
So nothing changes, right?
Right, exactly right, because it's just going to wherever head is what it already is. So, and if I just don't give it an argument, that's what you're going to get, right? Or, you know, if I give it git reset, then that's also the default is mixed. You know, it's the same as saying this, which is the same as saying this. So it makes some assumptions about what you're doing. And it, you know, it helps you understand what's going on if you know those assumptions being made. What do we want if we want to add this file in along with the other file? What do you think would be what would we want to do to this graph, or you know, to make that happen? We just want to take that commit back out and have that other file right next to this file, so that we can commit them both together.
We could cheat by using git commit amend, but that's a shortcut.
You could, and that, you know, that actually does under the hood exactly what we're talking about here. It's sort of a convenience wrapper around this stuff. Exactly right. So if we did not do that, what would what does amend do under the hood, do you think?
Probably does git reset head and then the tick, right? So one level up.
Yeah, one level back, which would be so here's a little Git sort of syntax for you. The caret in this context means the thing before head. And if head was a merge commit, it would mean the first thing before head. You know, the first parent before head. You can actually decide which parent you want to reference, but this one, you know, if you just do this, it says give me whatever the first parent before head is. Which, if you look at our graph, we're going to be right about here, right exactly here. And if we do mixed, looking at our table, what's going to be changed? Soft changes head. What does mixed change?
Moves the head.
Yeah, head and the index.
Yeah, that's right.
So, so I wonder.
Well, we don't have anything indexed.
Yeah.
Like, we don't have anything in the index right now, so.
Right. That's true. The other consideration is the file that we're pulling back out, or the commit we're pulling back out. Really, we don't need to modify it. So it can actually it doesn't have to go all the way back. You know, we don't need to change the index. In other words, we can just change head underneath it and have it be in the index already, basically, as if you do -soft. So let's try both of those ways to see what's going on here. So here's soft. Git status. So what happened there?
If you do adog, head will be pointing to the BFEA.
Right, exactly. And actually head is still pointing to master, but master now points to BFEA, right? Because head is a symbolic reference. So the symbolic reference didn't change, but the resolution, you know, the place master pointed did change. Okay, so that's one thing that changed. Anything else change?
We got the file back into the index instead of just the workspace.
Yeah, so yeah, this is a little nuance. The file actually was already in the index, right? And all that we changed was head. We actually did not change the index, and we did not change the workspace. We just changed what was kind of, you know, underneath, so to speak. But now what the status is telling us is that now head is no longer the same as our index. The index didn't change because there's, even if your Git status shows nothing, it doesn't mean there's nothing in the index. It just means the index is the same as head, right? And the same as your workspace. So conceptually, there's always something in the index. It's just a question of what it is with respect to the other two. That helped me when I was able to make that distinction. So now this change, it shows up as a change because now head is different. The index hasn't been touched. Does that make sense? We just moved head out, kind of back away from it to the previous commit. But yeah, so now hi.text is still fine. Now we can just sort of put their.text right next to it. Oops, git add their.text status. So now they're both next to each other, just like we wanted them, right? And now we can just do a git commit again. And everything's happy. I just did a queue for the quit from ADOG, and now I do ADOG again. And there they are. And I can do a git show and reassure myself, yep, that's what I wanted. So all is good. So we used reset to do something useful, to modify a commit and not we've not cluttered up. Notice in our ADOG, we've not cluttered up with a commit that we don't understand why it was there, which is handy. Commits can get cluttered fast. You can kind of see some of my stuff down here, which we'll cover next week on how to clean this stuff up. But you can just make little small changes and more small changes, and it really is not. It doesn't make much sense to somebody that hasn't been looking over your shoulder the whole time. So there are ways you can squash all those commits together into one and just push that one up. And it's tools like this to let you do that. So okay, so there's one example of git reset. So how does a git reset differ from a git checkout? I do git checkout -b a branch. What changed there versus doing a git reset?
So the checkout changed our workspace if there are different files and branches. And then it can also change the index, I guess, if there are uncommitted files.
Okay, yeah, so if I did a git checkout master, changes the workspace potentially. Okay.
I mean, changes the head to, where the head is pointed to.
Yes, exactly. Yeah, notice here, we did a git reset and head still pointed to master through a git reset. No matter what, soft, hard, or whatever, a reset always changes head to something, or actually changes what head points to something, but the symbolic reference is the same. I was already on master, wasn't I? Let's check out something else just for fun. Let's go back to some new branch. Straight this point. Yeah, so checkout, makes this different, makes this symbolic reference different. Reset leaves the symbolic reference the same and moves the thing that it moves the branch, not head, so to speak. So yeah, and Yeah, that's basically this fundamental difference. Checkout is kind of gonna, you know, change your index and change your workspace potentially. Reset may not change either one. You know, if you do a dash dash soft, it will leave both your index and workspace alone. So, okay. Any questions thus far? So let me give you, let's do it a little bit different here on this section here, moving a change forward. Let me give you about, 15 minutes to work through this section here on, you know, moving a change forward and then moving the change backward as well. And, you know, then we'll come back in, you know, about 15 minutes at, let's see, 11:50 and finish up there. But yeah, just give that a shot and see if that makes sense to you about how you're, you know, how the changes flow forward and backward using add commit for forward and then, you know, reset for backward, and see if any questions come out of that, and then we'll finish up from there. And I'll just stay online here if anybody has anything they need to ask or comment on.